The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Introduction and Technical Tour of DB2 10.5. And our guest speaker today is Ashish Mondal. He's the IT analyst with Tata Consultancy Services. Ashish Mondal is currently working for TCS as a product specialist and have an extensive experience in DB2 data warehousing concepts. He has worked in various domains including BFS, retail, manufacturing. He is currently heading data management part of IBM Information Management Software and has been assigned the responsibility to incubate IBM DB2 BLU in TCS. He is a BTech and also IBM certified DB2 DBA for LUW. He likes to explore best practices and upcoming trends in database management systems. So, without further delay, I introduce you all to our guest speaker. Over to you, Ashish.
Yeah, thanks, Aradhana. Yeah, good afternoon, everybody, and thanks for joining the webinar. So today I'll be presenting a session on IBM DB2 10.5 for BLU for LUW with BLU Acceleration. Last year, IBM launched DB2 10.5 with BLU Acceleration. And it has come up with so many innovative features. We'll discuss all this in detail. So let's start with the agenda. Yeah, so we'll be discussing what is DB2 BLU, and what are the 7 big ideas that led to the emergence of DB2 BLU, and how we are going to get the performance boost after implementing these ideas in typical analytical workload scenario. And then we'll have a question and answer session at the end of the session. Okay. So moving on to the next slide. Yeah, what is DB2 with BLU Acceleration? So let's start with the name itself. We all know it's a BLU technology. So what does BLU stands for? Is it the synonym for the IBM research project named Blink Alpha? Or is it, as some of the satisfied customers say, big data, lightning fast, or ultra easy? Frankly speaking, I don't have how DB2 has worked on, or it has given importance to all the 3 hardware parameters, hardware computing resources. The degree to which BLU Acceleration technology is optimized for the entire hardware stack is very strong. Whenever you think about the traditional approaches to performance tuning, you are likely to focus on 3 areas, and these are memory, CPU, and I/O. We don't know of any other vendor who has put so much of engineering effort in their in-memory databases like IBM. So in this diagram you can see what are all the optimizations that led to the effective resource utilization of memory, or the effective utilization of I/O, or the effective utilization of CPU. Now moving on to the next slide. Yeah. The 7 big ideas behind the DB2 emergence, or which the big ideas which led to the existence of DB2 BLU. These are, the number one is simple to implement and use. IBM has made DB2 BLU very easy to use. We don't need dozens of parameter controls. We don't need software system. We don't need exotic hardware. We don't need secondary servers. So we can make use of DB2 BLU with our old existing hardware. Whenever we talk about the administration of DB2 BLU, we discuss more about what we don't need to do rather than what we need to do. We don't need physical design tuning. Operational memory and storage attributes are automatically triggered. We don't want to spend time in creating indexes, creating entities, dimensioning data using multidimensional clustering data, distributing data with partitioning key, providing optimizer hints, reclaiming space, collecting statistics, and much more. A lot of things have been automated in DB2 BLU. It has the ease of just load the data and fire the query and enjoy performance gains. That's it. And one of the reasons it is easy to use is it uses the same DB2 process model, same storage construct, same buffer pools, same SQL language interfaces, same administration tools. So it's not an add-on to DB2 technology. It's the same old DB2 technology. Moving on to the next slide, we can see IBM has introduced a single registry parameter DB2 workload equals to analytics in order to convert the database suitable for analytical workload. So with the setting of a single parameter, a lot of things are automated. Say we have memory parameters, workload management, storage attributes, all are automated. And in DB2 10.5, IBM has introduced a brand new utility called DB2 Convert. With the help of this utility, we can convert our traditional row organized tables to column organized tables. And if you want to know, like, what are the tables which we should convert in order to gain some performance, so we can make use of a tool, Optim tool, known as Optim Query Workload Tuner. It will help us to identify the tables which can be converted to column organized tables, and also it will tell us the percentage of performance that we can improve after converting it to column organized tables. Moving on to the next big idea, it's compute friendly encoding and compression. The second big idea pertains to how DB2 encodes and compresses data and the way it packs the CPU registers. We call it actionable compression, but it is also known as delayed materialization or late materialization. It uses so many compression algorithms, out of which one important compression algorithm is Huffman encoding. Huffman encoding looks for the symbols that occur most frequently and gives them a sort of representation. You can think of it like this way: something that is appearing many times, that should be compressed more than other things that is occurring very less often. Let's take an example. We have a table called employee, where we are storing the employee details, say employee name, employee ID, year of joining. So we see that in employee name, the name Sumit has been repeated many number of times. So what it will do, it will assign a fewer number of bits, let's say 0 to Sumit. So the idea is it will assign a less number of bits to the value which is occurring very frequently in the table or very frequently in the column. And one of the important point to note here is it's dynamic in nature. This is something that a major competitor's technology cannot do. That technology is DBA requires to drop and manually redefine the compression matrix to adapt to new data. The important point is that BLU acceleration can dynamically alter the compression bias using the adaptive compression for new data loads that changes the distribution of common symbols, and thereby it ensures continuous optimization. Now the another algorithm that is used in BLU acceleration is offset coding. Offset coding, it's very useful with the numeric data or the kind of data that we use in financial applications. Let's take an example. Let's say we have an employee table where we store the bonus given to each and every employee. So we see that it varies from the range 3000 to 3200. So what DB2 will do, it will store 3000 as the base value, and then it will offset the remaining value. Say another employee gets $3,050 as a bonus. So it will store only 50. So this is the way it stores numeric data. Now one important point to note that the values in BLU acceleration compression dictionary, these are ordered. Let's assume the value 3200. It compresses to like 10, and for 3000 it uses 01. So we can see that these two values are ordered. 01 is less than 10 as 3000 is less than 3200. So as a result, DB2 can perform a lot of predicate evaluations without decompressing the value. Let's say we have a query where we want to use select star from employee table where bonus less than 3200. So how it will use? It will simply convert the HUI to select star from employee where bonus less than 10. So in this example, DB2 can filter out the values that are greater than 3000 and less than 3200. So here we can see DB2 has to decompress only the qualifying rows, and this is a tremendous performance boost. Now BLU acceleration takes the symbols bits and packs them as tightly as possible into the width of the CPU register. So when we sum up all of the idea components in this section, it will lead to the better I/O because the data is smaller, which leads to more density in the RAM, optimized storage, and more efficient CPU, because we are operating on the data without decompressing it, and this leads to CPU usage reduction. And in another way, we can say that we are gaining in terms of performance. Now moving on to the next slide. The next big idea is multiply the power of CPU. The third big idea is leading edge CPU technology found in today's modern core processor. that is called SIMD, single instruction multiple data. SIMD instructions are nothing but low-level CPU instructions that enable us to perform the same operation on multiple data points at the same time. It automatically detects and senses the environment and dynamically optimizes the runtime accordingly. So we don't need to do anything. DB2 will automatically senses the number of cores, or it automatically senses whether the processor is SIMD enabled or not. It can put 128 bits into a SIMD register and evaluate all of the data with a single instruction. And this is why this big idea is so important. Being able to compress the data as much as possible, compress the most commonly occurring data, and then optimally pack it at register width. This reveals the synergy that lies at the core of the DB2 BLU. Now, moving on to the next slide, the next big idea is code-friendly parallelism. Code-friendly parallelism is a very powerful idea. DB2 BLU leverages the processing codes that are available on a server. For BLU acceleration, main memory access is too slow. Whenever we say that the main memory access is slow, we compare this with the access to CPU cache. BLU acceleration is designed to access data on disk very rarely, access RAM occasionally, and do the most of the processing from data and instructions that reside in a CPU cache. So we don't want to retrieve the data from disk again and again. It recognizes the servers that have increasingly larger number of cores, and it is designed to take advantage of the code automatically, so that it can always derive multi-core parallelism for all the queries that we run. Moving on to the next slide, the column store. When we say column store, we mean that a single page in the database stores the values of just a single column, which means that whenever the database engine performs I/O to retrieve the data, it just performs I/O for only the columns that satisfy the query. As in case of traditional database, we used to retrieve the entire row, that is all the set of columns. But here in the case of columnar store, we are only bringing the pages into memory that are mentioned in the query, or that satisfies the query. Here we are directly working on the columns. By using the column store with encoding, DB2 is able to get an additional level of compression, due to which I/O has been reduced. It is able to perform predicate evaluation against the compressed data by using late materialization capabilities. So with the use of columnar store, we can see that the I/O has been reduced a lot. Now we are only interested to fetch the pages related to the particular column, due to which we can put more and more data into the memory as well as in the CPU. Moving on to the next slide. DB2 uses a scan-friendly algorithm for memory caching. So at the first point, For columnar store, we retrieve a page which contains the column. But when we need to fetch hundreds and thousands of pages, and when we'll put it into the buffer pools, we use this algorithm, we use a term called interesting pages, which we use to flag it on, and we use to keep it in the RAM rather than flushing it off. So this is some kind of smarter algorithms that we use in DB2 BLU. Also here we can see that the data can be larger than RAM. Here we don't have the rigid requirement that the entire data has fit into memory. We just need to use the optimal caching. Now moving on to the next slide, that is data skipping. DB2 is able to skip the data that is of no interest to our active query workload. For example, if a query was to calculate the sum of last month's sales, we don't need to look at any data that is older than the last month. So with this technology, DB2 can automatically skip the non-qualifying data, and it implements this data skipping with the use of synopsis table that is automatically created for all the column organized tables. And in this table, it stores the min-max value of each and of the data values of type numeric, or we can say the date time. Let's say in table we have employee bonus. So it will store the minimum and maximum value of the bonus stored in a single page. So this is a way we try to skip the data. Let's say we are only interested in 2014 data. So we'll not look for the data that belongs to the previous year. We have a synopsis table which will point that 2014 data resides in this particular page. So we will only be interested in fetching those pages to the buffer pools. So this is how DB2 BLU implements data skipping. Now moving on to the next slide, we see how DB2 with BLU acceleration, it improves the performance, or it gets the performance boost when these big ideas come together and implement in a single use case. Let's take an example. Let's take the scenario where we have a 32 cores of processor, and we have a 10 terabyte table with a relatively wide number of columns, say 100 columns, and it stores 10 years of data. Now the database stores 10 terabytes of raw data, and the analyst is willing to execute the query. Select count star from my table where year equals to 2010. So we can see here, currently we have 10 terabytes of data, 10 terabytes of raw data. Now, assuming that we are getting 10x compression, the effective data volume comes down to 1 terabyte. Now, since we have 100 columns in the table and we are interested in a single column, year equals to 2010. Now we have 100 columns in the table, and we are interested in a single column. So we will be fetching only the pages that belongs to a particular column. So we divide it by 100, and the effective data volume comes down to 10 GB. Now when we implement data skipping, that is, we are interested in a particular year out of 10 years of data, so the effective data comes down to 1 GB. Now we can see that 10 terabytes of data has come down to 1 GB effective data. Now since we have a 32 core processor and DB2 BLU will leverage the parallel core processing, the effective data is slashed now to 32 bits, 32 megabytes. Now it will also make use of SIMD processing, SIMD parallel processing in all the cores. So we can see that the 10 terabyte of data will be slashed down to 8 MB. And it can be fetched in a very, very less time. We can say sub-seconds. It won't require a second to fetch all these data. So the intention of DB2 BLU is that it reduces the active workload. In this diagram, in this example, we can see that we started with the 10 terabyte of data, and now that active workload has reduced to 8 MB. After implementing compression, columnar technologies, data skipping, cross-core parallelism, and all big ideas. So I must say that we should go for BLU. We should try it and see the performance. And that concludes today's session. Here are the references. All the snaps are taken from IDEB presentations, International DB2 User Group. Thanks everybody for joining the session. Now I'm open to questions.
Thanks for the insightful presentation, Ashish. Let's quickly take up the questions now. I would request you to read out the questions and their answers so that all our users may listen to your insights.
Yes. So can we have the questions now? I'm not seeing any question in that.
Yeah, are you able to see them now?
Yes, suppose if we would like to implement for the current version 9.1, then what would be the effort? Yeah, there is a question from Kiran Kumar. He has asked, suppose if we would like to implement for the current version 9.1, then what would be the effort? So currently IBM has recommended that we should first upgrade DB2 9.1 or the earlier versions to DB2 9.7, and then we can upgrade it to DB2 10.5. We cannot directly go to DB2 10.5 from the earlier version, earlier than DB2 9.7. So the first step is we should upgrade to 9.7 and then we can upgrade to 10.5. The next question is from Janmeje Dvedi. How DB2 differs from SQL? I don't know what he means by this, because we use the same SQL. I mean, whatever we were using in earlier versions, let's say DB2 9 or DB2 9.7, it's the same in DB2 10.5. There are no changes in SQL. Now, there is another question from Rajesh Prabhu. Can you please tell me a real-time case study that was implemented with BLU Acceleration? So you can see a lot of presentations from IBM, or a lot of they have shared, so many customer testimonials, such as from BNSF Railways or Coca-Cola, where they have implemented this and they have gain a huge performance boost in their analytical workloads. The next question, can you compare DB2 Blue versus Oracle 12c features? This question is asked by Rangarajan Balakrishnan. So I would like to say that I don't have much insight into Oracle 12c features, but we can definitely find it we can Google it. Next question is from Naveen Potla. What are the parameters that we need to set to enable Blue? We have single registry parameters that need to be set, that is called DB2 workload equals to analytics. Once this parameter is set, our database will be enabled for analytical workloads, or we can say whenever we'll create any table, by default the table organization will be columnar table. We also have the freedom to create the row organized tables. For that we have to include organized by row at the end of the table creation DDL. And all the parameters will work as it is in the previous versions, like our STMM will be enabled and it will be more suited for analytical workload. The workload manager will be pre-configured. Next question is from Pawan Kumar Singh. I have already implemented DB2 on 10.5, then moving to Blue. Is it upgrade or new installation? See, currently DB2 has come up with two different editions. One is called AESE Advanced Enterprise Server Edition and the other is Advanced Workgroup Server Edition. So we don't need to install anything. We just need to install DB2 10.5 and based on the licensing that we have, we can make use of DB2 Blue. We don't need another installation or another upgrade. If the product is licensed for AESE or AWSE, then we can make use of DB2 Blue. There is another question from Rohit Lamba. Can we use group by queries in SQL? Yeah, we can definitely use group by queries. There is another question from Kiran Kumar. During the migration from DB 9.7 to 10.5, does it impact on the data? There is no impact on the data. It's just the architecture behind the DB2 that will change. In DB2 9.7, the data was organized as row format, and in 10.5, if we convert it to an analytical database or the Blue database by setting the parameter DB2 workload equals to analytics, the data will be stored in columnar format. That is the only difference that we'll have when we migrate it from 9.7 to 10.5 in terms of data storage architecture. And I received one request from Rajesh Prabhu. I just wanted to inform everybody that DB2 user group meeting is organized in IBM EGL campus on 21st of June. It's regarding Bangalore DB2 user group. It will start from 9:30 to 4 o'clock in EGL campus, Bangalore. Next question is from Bharat Karumudi. How DB2 Blue manages reorg and run stats? So the only difference in 10.5 is that reorg and run stats, these are automated. We don't need to run explicit reorg or run stats, though we can run it if we require that. In DB2 10.5, whenever we delete any data from the table or whenever we delete any data from the pages, the space is automatically reclaimed and added to the table space. So we don't need to run a reorg and run stats. We have another question from Naveen Kotla. If we convert row to column organized tables in DB2 10.5, is there any option to revert that changes from column to row organized tables? There is no, we can say, parameter or way to convert from column to row organized tables, but there is a single way we can export the data and again reload it. We can export the dump and then load it again to row format tables. There is another question from Pawan Kumar Singh. What is by default data format in DB2 10.5? Row based or columnar based? See, whenever we say default data format in 10.5, we don't have any default. The thing is, if we set the registry parameter, that is DB2 workload equals to analytics, then the default table will be organized in columnar format. And if you want to create a row format table, then we need to add organize by row. If we don't set the parameter DB2 workload registry parameter DB2 workload equals to analytics, then by default it will create row format tables, and then if we want to create columnar tables, then we need to add at the end of the DDL table DDL organized by column. Any other questions?
We are waiting for the questions to come in. So while we wait, would you like to give a little more information from your end about this session?
I believe I have shared all the basic information related to DB2. But yeah, I can share some more information like DB2 BLU. Currently, it has been launched in AIX and Linux versions only. Currently, it is not available for Windows, and for Linux, it has been available on SUSE Linux and Red Hat Enterprise Linux Server. There is one question from Pawan Kumar Singh. How is it different from SAP HANA DB? See, the SAP HANA, I believe it's a in-memory database, but in DB2 BLU, it's in-memory optimized. Here in DB2 BLU, we don't have the requirement, rigid requirement, so that the entire data has to fit in memory. Here the data accessed by the query can be larger than the RAM. It's just we need to work on optimum data fetching. But in case of SAP HANA, I believe we need to assign more and more memory equivalent to the data we have in the database. So that is the primary difference. Also, SAP HANA, it's a columnar database, but here in DB2 BLU, we have the freedom to create tables of both the types, row format tables as well as column organized tables. Any other question? There is a question from Naveen Kotla. What type of reorg it will do, offline and online? See, the thing is, whenever we perform any update or any delete statements, the organization of the data will change at the back end. We don't need to run the reorg. Whenever we delete any data from the DB2 tables or it will directly delete it from the pages, and the space will be automatically reclaimed. So we don't need to run in any reorg in DB2 10.5. There is again one question from Naveen Kola. Will BLU support federation? I believe it would be there in IBM's plan. They might come up with this idea, but I cannot say anything on this. If there are no more questions, Aradhana, I feel you can wind it up. There is one more question from Bharat Karumudi. What about HADR in BLU? So currently it doesn't support HADR facility, but in the later improvements we may have it, or IBM can come up with this in the next update.
Thanks, Ashish, for your time. I can see that you have answered most of the questions. I think all of the questions now. So if you would like to sum up the session for today, you can do it now.
Okay. So I would just request everybody, if you face any problem in migration to DB2 10.5, or if you face any difficulty in migrating from some other databases to DB2 10.5, you can reach out to me. You can contact me at assish.mondl@tcs.com. Thank you very much. Thanks for listening to the session.
And I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Ashish, for taking the time out and having us. I hope you have a great evening ahead.
Yeah, thanks, Aradhana.
Bye-bye.